as we prepare for the next question. So we have question number 6 here. We have, write the electron configuration for the following ions, okay? The electron configuration, the ions they give us are, so electron config for the following ions. We're given A, nickel 2+, B, cadmium 2+, C, zirconium 3+, and zirconium 4+, and D, it's osmium, I think, 2+, and Os3+. Okay. So let's start with the nickel first, but first let's just write out in terms of our whole off-ball principle. We have 1s, 2s, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p, and then 3d, 4d, 5d, 6d, and then 4f, 5f. Okay, so now let's look at the periodic table. So nickel, okay, is the 28th element. So 28th element. All right. So we want to be able to cross through all the different shells so to get to the 28th element. So the first thing we'll see is that hydrogen and helium count as your 1s row. Okay, so we have the 1s completed just like that, because we have now 1s2 as we're trying to make it our way all the way to nickel. Okay, so now we have 2s2 for lithium and beryllium, and then the p shells right here, starting from boron to neon, columns 13 through 18 excluding helium, are where the p orbital is going to be, so it'll be 2p6. Then we have the same 3s2, followed by 3p6, and now we have 4s2 followed by 3d8. Okay, so with this being said, we have to make sure that we actually have the right element here. So we're going to add up all the superscripts. So we have 2 plus 2 plus 6, that's 10, 12, and 18, and then plus 2, that's 20, and then 3d8, that's 28. Okay, which does match the nickel. But now in order to find the electron configuration for nickel 2+, we have to get rid of 2 electrons. Now, personally, I would actually propose to get rid of the electrons in the most outer shell, which in this case would be the highest coefficient. And in this case, we have the 4s. So I would argue that the electron configuration for nickel would be 1s2, 2s2, 2p6, 3s2, 3p6, and then just 3d8. Just so that way we have removed the most valence electrons. And we'll see if we can keep this up for the rest of these metals here. I believe they're all transition metals. So cadmium, okay, is all the way here, element number 48. So for this one, I'm going to now tackle the shorthand, because hopefully now you'll be able to track down how I was able to build up to the 4s2 3d8. So for shorthand, just to be able to actually use that as well, we start with our most recent noble gas, which is krypton, okay? And then we just proceed to count again as if you were starting from scratch. So for cadmium, it's on the 5th row. So we have 5s2. But then to cross through all this d orbital to get to cadmium, it would be 3d10. Okay, whoops, sorry, not 3. It would be 4d10 because you only subtract 1 from the row you're in. Okay, so that'll be it for now. So now to find out actually the specifically what would be given up for cadmium 2+, I still contend that it will be its most outer shell. So for cadmium, we'll have krypton, and then we'll have just 4d10. Okay. And now for zirconium. Let's see what we have here. Element number 40. Okay. So once again, we'll start with the most recent one. That's krypton. Okay. And then once that's done, we now continue on. So it'll be still 5s2. But krypton shows up, well, it's not krypton. Zirconium shows up a lot earlier. It'll be just 4d2. So it's 5s2, 4d2, okay? So now the question is, which one would it get rid of first? I still personally think that because 5 is the greatest coefficient, it'll get rid of this first. Whoops. It'll get rid of this first, and then, so sorry, it'll be 4d2. It'll get rid of this first, and then it'll subtract 1 from the zirconium. And then if that doesn't work for the 4+, it'll just get rid of all of these. So for this, I have, it's going to be 5s2, 4d2. But because we want the zirconium, it would actually just be 4d1. Okay, that's what's going to happen here for that electron configuration when it's zirconium 3+. For zirconium 4+, it would just be this as its shorthand. Okay, so far that's A, B, and C. And now for D, we have osmium seams, which is element number 76. So first we'll do the shorthand. So xenon will be our most recent element. So we have xenon, and then we have 6s2 still. But we, as you notice, we actually passed through the lanthanium series. So with that being said, we actually have a 4f14 here. Because that's the only for you to get out and get back to what this was. And now we have 1, 2, 3, 4, 5, 6. So then for the osmium to land there exactly, we need 76, 6, 5, D6, I believe exactly. Okay, cool. So now we have this. It's Os2 plus and Os3 plus. So for this, I will once again contend that we have our most outer shell, which is going to be this. Okay. And then Os3 plus will be 5d5. Oops. Sorry, wrong outer shell. This will be our outer shell. And then we get 5d5 for the Os3 plus. At least that's my theory. We will have, this is shorthand, 4f14, 5d6 still, which is good. And then for the one of the Os3 plus, we have same thing here, 4f14, and then 4d6. Oops, sorry. 5d5. Sorry, I was just decreasing the wrong part. But exactly, see? That way, I was now able to account for all the electrons that may have gone based on the ion given. So, even if we were to count, so xenon, as we did the shorthand, is the, sorry, let's see here, 54th element. So 54 plus 2 plus 14. So that's 54 plus 14. That would actually equal to 68. Plus 2, that's 70. And then plus 6, 76. And you'll see the 76th element is indeed osmium. So this is what we would have for this question in terms of the electron configuration. Let's see how we did. So nickel, we got rid of the right one. We have, sorry, I think I put 4d10 there. It should only be, oh no, that's correct. For nickel, we have this here, 3d8, which is really good, 4s0. For cadmium, we have 4d10. Don't know why I didn't. I'm just making sure. Cadmium, I should have, oh, it's 48. So I don't think I put, oh, there it is. I was looking at the wrong answer. So 4d10 indeed, which is what they got for cadmium. Then Zr3 and Zr4, that's where we have this. I believe this one's a little bit more complicated because what I did here, I kept the d orbital and decreased the s orbital, but at least the 4 plus, both of ours are the same, but that's only because of the fact that they got rid of, into Zirconium where it is here, they got rid of both the d orbital, which is the 2 there, and the 5s orbital, which is the other 2, hence how we could just get this as the next answer. In regards to why they kept their s instead of their d orbital, which is a 4d1, that one's a little bit of a mystery, and you can see here these ones are the same thing as well, to where they keep keeping the s orbital and getting rid of the d orbital. So I would say that the d orbital, in my opinion, would be the one that makes the most sense to keep, considering that they are closer to the nucleus, and even though there is electron shielding, there's a lot more shielding that happens in the outer layer, which is why I think it would rather shed that one first. But nonetheless, we do have a little bit of conflicting answers. I probably said this is correct though, just because overall they understand the concept. It's just more so making sure that you subtract correctly when trying to decide what your new electron configuration will be. So let's move on now to question number 7.